As the water boils, the air gets trapped up here and has nowhere to go, and the air expands, and it pushes the water down this little tube at the bottom of the coffee maker, and then the air pressure pushes it down, the vapor pressure, and then it'll push it up through this tube and into the top chamber. So we lost about 15 grams of water, and when I did the calculation, we lost 4.7% of the water while the coffee was boiling. So I put both of the graphs of the frequencies of these, and I found constructive interference both on the bottom and top, and the top over here and the bottom right here, and the rest is kind of just destructive, but they're beats, every 2.5 seconds, but the most noticeable one is going to be every 10 seconds at these two tops right here. So I put in all these indices of refraction. I'll do the math of that in a second. And I also put up a little diagram of how the fish is going to look from the lens. So the same fish, it's going to look like it's both here and here, but it's really here just because of how the light is coming from your eye and how it's hitting the acrylic and then the water and how it's going to change, but how the fish is really in the middle. Let's pretend like I was looking at a 45-degree angle at the tank from the camera. The critical angle of the acrylic is 45 degrees, so I can see in the acrylic and tank. So I look in and I do this math with the indices of refraction, and I find that, and that's from air to acrylic, and then we look from acrylic to water, we find that our final angle is 32.11 degrees difference. So FM bandwidth 95.7 is 95.7 megahertz in frequency. So in hertz, it would be 95.7 times 10 to the 6th. So the period of that is 1 over frequency. So 1 over 95.7 times 10 to the 6th hertz is 1.045 times 10 to the negative 8th seconds for each period. So right here, I'm casting my lure, and it's going to hit the water, and it's going to go, the ripples from it are going to go against the ripples from the pond, and they're going to create destructive and constructive interference in certain places, and this is pretty much a diagram of what's going on as it's going through the pond. So right here, I'm casting my red lure into the deepest part of the pond, and as it gets deeper to around 8+ feet, that red light that has the lowest frequency will actually not show up as much, and it'll kind of just turn into like a gray or black because the red light scatters and gets absorbed because it's such a low wavelength of light. So right here, I'm going to cast my lure with my rod, and it's a pretty light rod, so it'll bend a lot. And as I'm casting, it increases the potential energy in the rod because it's so flexible and the rod bends so much. So this is the point of highest potential energy. As you can see, the rod is bent at more than a 90-degree angle, and it's like a big spring, and it'll go back to straight and shoot the lure forward. So right now it's at its highest potential energy, and it's about to give all that kinetic energy into that lure and throw it very far. So right here when I put my glass down, there was a big block of ice in it, and it was very well balanced, and there was almost no friction between it and the glass, so it just kept on spinning at the same rate around and around because there was no friction, because there was a little layer of water in between it and the glass. And it enabled it to follow Newton's first law of motion like almost perfectly. So, Bernoulli's principle is how lift is created, and lift is created on a sail by the same wind having to travel two different distances. So, if it goes around the outside, it's going to have to travel faster to get to the end and the inside, which creates a low pressure zone because there's like less air on the far side, and there's high pressure on the inside, which will push to the outside and create lift and propel the boat forward.